What's up, guys? Welcome to lesson 1-5, words, equations, tables, and graphs. Let's do it. So here we're going to start with number 6, and it says today's attendance is 4 less than half of yesterday's attendance. And then it says complete each table, state domain and range. Now we don't have to make a function. It doesn't say we need to, but it's a little easier if we do. So it says that today's attendance, which is y, is, which is equal, 4 less than half of yesterday's attendance. So yesterday's attendance is x. So it says y is 4 less than half of yesterday's attendance. So we're taking half of x, subtracting it by 4, and guess what? We get y. So that's the relationship between x and y. Now it's a little bit easier to come up with our y values since we have this function. So when x is 14, what is y? Well, we plug it into this function. We say, oh, it's half of that, half of 14, minus 4. Well, what's half of 14? That's 7 minus 4, and that gives us 3. So then we go ahead and plug 3 into this table. Next, we have 18, so we plug 18, same thing, half of 18, minus 4. What's half of 18? That's 9 minus 4, and that gives us 5. Okay. You see now you can kind of do it mentally. Half of 22 is 11 minus 4 up here, which is 7. And then finally we have half of 26, which is 13 minus 4, which gives us 9. And it's a cool little pattern. You see this one goes up by 4 every time, and this one goes up by 2 every time. It kind of makes sense. So now the question is, what is the domain and range? Remember, domain is simply our x values. So this is our domain right here, 14, 18, 22, 26. And the range are simply these guys, 3, 5, 7, 9. So that is number 6. Now let's go on to number 10. All right, so 10, it says sales for a new video game offered by Techno Games is shown at the right. So here's our little table here. It's a little hard to read, did my best, but basically this value right here is 180. This value right here, you can kind of read this as 1, 2, 3, 4, 5. So again, look, the input, which is our x, this is months down here. Let me write months down there. And here, this is games sold on the y. Just write games. So that's what's going on here. And it says we sell, at 1 month, we sell 180. At 2 months, this is actually 165. At 3 months, this is 150. So you notice it's kind of dropping in increments of 15. So it says make a function table showing the input and output. So let's go ahead and do that. Our input is simply month, and our output is games sold. And our input, we already can see, it's just, we got 6 points. 1, 2, 3, 4, 5, 6. Let's go ahead, month 1, 2, 3, 4, 5, and 6. You can even segment it off like this, make it a little clearer. Oops. Not the best line there. All right, so here we go, 5 and 6. Okay, now let's take a look. So at 1, I'm telling you this point right here, this is 180. Okay, so that means right here, we got 180 games sold at month 1. What about month 2? That's 165. And it literally, if you look at the table in your book, it just drops by increments of 15. It's actually linear. And then next we have 135. Then we have 120, and it ends at 105. That's how you make this table. That's really all there is to it. Now let's go on to part B. So part B, write an equation that can be used to find the number of games sold, G, for any month, N. Okay, so how do we do this? Well, again, M is kind of like our input, right? So it's G is going to equal some function of F. Well, let's think about that for a second. When m equals 1, okay, when m equals 1, g equals 180. But as we kind of go down this line, okay, then m equals 2, it equals 165, equals 3, 4, so on and so forth. So how is this going to make sense? Well, if we kind of carry this back, at 1 it's 180. Basically at 0, we can kind of assume that now games sold at 0, it might have, well, of course you can't sell any games at game 0, but if we kind of carry this rationale back, we may have sold 195, right? 195. Actually, no, let's not do that because that presupposes something was sold at month 1. Instead, we'll kind of go like this. We'll say it's 180, okay? 180 minus, and then what we're doing is every month that goes on, we're taking away 15. But really, since at month 1, I'm making it a little complicated. You don't have to make it this complicated. At month 1, okay, since we're taking away nothing, it should be m minus 1, because at month 1, this guy is going to be 0. m minus 1 times 15. What this does is this means that at month 1, we're going to get 0, so we're just getting 180 for games sold. At month 2, then it becomes 2 minus 1, so it becomes 15, and it'll give us our 165. This is all going to match up with the table. Or you can do it the other way that I was about to do it. Might make more sense. It's 195 minus m times 15. If you like that better, go with it, because then this is basically when m equals 1, we got 195 minus 15, that gives us our 180 for G. When m equals 2, that gives us our 165, so on and so forth. But this is how you make an equation to do exactly what the question is asking. Now let's end with part C. Is the set of ordered pairs month games sold a function? Okay, so the definition of a function is essentially, whether or not you could just, hopefully you've learned the vertical line test, but basically for every x value, for every y value, there has to be a unique x value. You can't have x values repeating. And if you, the reason why we call it a vertical line test is if you ever draw a line, let's say through one of the points like this, going all the way down, and with that line you hit 2 points. You hit 2 points on the function, it's not a function. But in this case, look at all our points. Every single one is going to pass this vertical line test. When we do a vertical line, we don't ever hit more than 1 point. Accordingly, this set of ordered pairs is indeed a function because of our friend, the vertical line test. And that's it, we are done.